Hey everyone, welcome to Studio Review. It's Kyle, and in this video, we're going to be going over unit testing. The goals of the studio were to become introduced to unit testing in Java with JUnit specifically, as well as understand JUnit annotations and structure. To begin the studio, we need to go out and fork the repository and check out JUnit-studio-LC101. We've forked repositories in the past, so I'm going to go quickly through this, but feel free to look back at past videos to see how we do this. And there we go, we have forked the repository and now our project is open into IntelliJ. In this studio, we're going to be writing unit tests to find the errors inside of balanced brackets, that class that's already inside of the project that we just forked. We also need to remember that we need to use TDD to get this class working. We should all remember TDD from our last unit, which stands for test-driven development. To walk a little bit more through this methodology, say we wanted to develop a dog class. Well, step one in TDD is to write those tests for the dog. Some tests I might include is, does the dog have a name? Does the dog have an age? And does the dog bark? Three very simple questions that our tests ask our dog class. If you see this too, it creates a sort of checklist. That's what TDD does, is that it creates a to-do list for us to help develop our class. If we were to run these right now, we know that we get failing tests all over the board. It's because we don't have a dog class written yet. So after we write these tests, we start writing the dog class, our second step. As we write our code in the dog class, we start to get passing tests. We continuously write the code for the test that we're focusing on specifically, and we make that one pass before we move on. That is the methodology of TDD, and that's what we're going to be doing today. So we need to create our own tests, and our studio specifically says that we need to create at least 12 tests. So the question that might be in your head right now is, what tests do we write? Well, what I usually start with when doing TDD is that I start with the happy paths. The happy paths are more of the ideal input that I would provide to my method. One example for this balance bracket method that we have to write tests for is just a simple open and close bracket. This is a very happy path, a very ideal input. And our balanced brackets method has to ask the question, do these have balanced brackets? I see that they do have balanced brackets. They have an open bracket and a closed bracket. Therefore, I expect this method that we're testing to return true. Let's look at another example. Say we have two sets of brackets now. Well, again, we ask ourselves, do these have balanced brackets? What would we expect back from the method? I see open and closed brackets used appropriately. So I expect this method to return true. Looking at another example, we're getting a little bit more complex here. We have brackets within brackets. Still ask the question, are these brackets balanced? And they are. So therefore, this should also return true. And as we move down in our happy paths, we should get more and more complex in our input. If we look at these very closely, we all notice that they all have balanced brackets. Therefore, each of these should return true. So this is one side of our tests. Let's look at the more dark side. So we just wrote tests for a happy path, an ideal situation. But on the far end, we need to write tests that are for those less than ideal inputs that a user could provide. So I'm going to be calling those not so happy paths. One example would be an empty string. The question we ask, do these have balanced brackets? Well, they do. They don't have any brackets at all. Therefore, technically, yes, they are balanced. So this should return true. Getting a little bit more complex, we say we have an open bracket, the word pizza, and then closed bracket. Well, technically still, we have balanced brackets here, so this should return true. Now looking at a different kind of example, we just have an open bracket, no closing bracket. Are these balanced? Well, no, it doesn't have a closing bracket. Therefore, we should expect this method to return false when it sees this kind of input. Moving on, we see just a closing bracket now. Well, this should also return false because it has no opening bracket to make it balanced. Two more examples is a closing and then an opening bracket. Technically, there is a closing bracket and an opening bracket, but they're not correctly aligned. The other input we see is pizza with an open bracket, another open bracket, and a closed bracket. These brackets aren't balanced either. So both of these should also be false. So mixing the test cases we have here with those happy path classes that we also created, we now have 12 cases that we can test for. We have those happy paths and those not so happy paths. So looking at this table, we see all these trues and then the falses on the right-hand side. These are our expected values. This is one part to our test that we need. So let's take a closer look at what else we need. Again, that expected value is what we expect or it should return from the method when we're testing it. The other part we need is the actual value. This is what is actually returned from the method or what truly gets returned from that method. Looking at our first happy path example, we have that open and close bracket, and it should return true. Our expected value here would be true. Our actual value, again, is what's returned from the method, so we have to call to that method in the balance brackets class. Now we take all these parts and we're going to create a test out of this. To test something, particularly in JUnit, and you might have seen it in previous coding languages, is that assert equals, which takes in two parameters. The first one is the expected value, and the next one is the actual value. The expected value, again, which should be returned from the method, which is true. The actual value is what's being returned from the method, so we actually place the method in there to get its response and match it against true. Another way to write this, though, is to use another assert called assert true, which just checks if whatever's returned from a method or another value is true. So we can use this and place that method inside of here to kind of save us a little bit of coding room when we're writing these tests. So in the future examples, I'm going to be using assert true. Moving on, we have that assert true now that takes in our balance brackets method. And now we need to actually write the test. And to actually write the test, we say public void and then the name of the test here. But this is just a typical method. We need to provide something additional here to tell the compiler this is a very special kind of method. It's a test. And so what we do is we put this @ then test above the method. Again, to indicate to the compiler, this is a test method. We call this an annotation. We're annotating the method as a test. Once we do that, we place the test code inside of the method. Going one step further, to write the test for this first happy path we have, we would call it something like only brackets returns true. And then we would place that assert true inside of this method. This here is how we would write our first test. So let's move to IntelliJ and do this. Inside IntelliJ, inside my JUnit-Studio-LC101 project, I go to the source folder, I go into test, and I see I have my balance brackets test here. Balance brackets test was created in order to test balance brackets class here. Like we said, we're going to write that first test to test if our first happy path works. So let's do that. How we said we were going to do that is with the @ and then test, which again is an annotation, and then public void, and then only brackets returns true. And then inside of here, we put that assert true, and then we call to the static method inside of balance brackets. And then we place our first happy path inside of there, that open and close bracket. Now to run all of our tests, I would click up here and press run, which runs two tests, the first test and then the second test. If I want to run my tests individually, I would click the green button to the left of that specific test, which only tests our only brackets returns true test. And everything looks like it's passing. Awesome, let's move on. So going to our 12 cases we have to test for, the first one is done, it's passing. So let's move on to the next one. I'm going to copy the past test I just did and paste it down here. I have to change the name. I'm going to call it 2 brackets returns true. Remember, these names can differ. As long as it makes sense to you and you feel like it's going to make sense to others, then that's what you should name it. But in the end, it's completely up to the developer. Here, I'm going to place that second bracket, and then I'm going to run this test individually. Perfect. All right, this test has been completed. Now let's do these 4. Again, copying that test from above just to save me a little bit of time. I'm going to call this one brackets within brackets. And that was our input. I run this. Great. Let's keep moving. This one's going to get a little bit more complex. I'm going to call it brackets of brackets within brackets. Again, we want to keep these names at least a little detailed so future developers know what's kind of going on in these tests. I'll run this. Great. I'm going to call this one triple brackets within brackets. Perfect. Run it. And it's passing still. And then finally one more, which I'm going to call this one two triple brackets within brackets. There we go. And then we run it. All right, perfect. Let's run all of them together just to make sure we haven't broken anything. And we have 7 passing tests. Remember, it's with the addition of this test up here that we have 7. We now have these 6 tests passing. So our happy paths are done. Now to move again back over to the dark side, not so happy paths. So let's do this one. Let's start with the first 2 here. Going back to IntelliJ, copy the test once again. I'm going to call this one empty string, returns true. And then I put empty string in here. And then I run this test individually. And it passes. Great. One more we need to create. I'm going to call it brackets with pizza. And here I put brackets and then pizza. And then I run this. All right, everything's passing so far. So now we're getting into a different test. Everything's been true so far. We see our next case to expect to be returning false. So looking at that one, if we bring in that not so happy path that's returning false, instead of using assert true here, we are actually going to be using assert false. Inside of assert false, just like assert true, we place that method that we want to test there with the provided input. So if this was to look like a test, this is what we're going to write. So let's do this. We paste our test. I'm going to call it only open bracket returns false. We said we're going to put assert false here now, and it's only that open bracket. Let's run this. So this case is done. Let's do these next 3. The next one is only close bracket returns false. Let's run that. All right, keep going. In this one, I'm going to call it mismatch brackets returns false. And I'm going to place a closing bracket and then an opening bracket, and we're going to run this. Uh-oh, we look like we got a failing test here. We have mismatching brackets, a closing bracket, and then an opening bracket, and this is not correct. It should be returning false, but it looks like it's returning true. It looks like this test is catching a bug inside of our code. Let's go back to balanced brackets and see what's going on here. Looking at our method, breaking it down to what it does is that every time it sees a opening bracket, it increments brackets by 1. And every time it sees a closing bracket, it decrements by 1. So going through this method with our example, if it comes to a closing bracket first, it's going to decrement 0 by 1. And then it's going to come through here again and see the opening bracket, which is going to increment by 1. -1 plus 1 equals 0. So we come down here and we see brackets equals 0. That means this method is going to return true, which again is not correct. So though our instructions don't specifically say we need to correct this bug, I'm going to do it anyway here to show you exactly how we can fix this bug that we're catching with our unit tests. One big thing I said during that explanation is that brackets at one point was a -1. If you think about it, never in a situation that has perfectly matched brackets should we ever get a negative number. If we ever do get a negative number, it is a clear indication that something has been mismatched. Because I know a negative number is not an ideal expectation of this method, I can now put an if statement inside of this for loop to see if my brackets counter ever hits a negative number. If it does, I can immediately return false because I know brackets should never be a negative number, otherwise it's a mismatch. So what I'm going to do is down here, I'm going to say if brackets is less than 0, indicating a negative number, return false. Going back to our test, and I run this again, I see now that it's passing. So this is great. This one test now is passing. But one thing I need to point out that though I corrected this problem, I don't know for sure if now every case will work. I can't be 100% certain. we now have 10 previous cases that need to pass in order for me to know that my fix for that bug we found works for every case. That being said, we have to go and rerun every test then to make sure we haven't broken something else that we haven't noticed yet. So we rerun this and we see that we're getting all of our tests passing once more. Perfect. Exactly what we want to see here. So let's go ahead and plug in that last test case that we have. I'm going to call this one unequal brackets with pizza. And then we run this one individually. And perfect, it's passing. Awesome. Just for good measure, we're going to run all of these one more time, and we see that we're getting 13 passing tests. Awesome job. We come back here, and now all of these cases have been fulfilled. Of course, last but not least, always remember to push this work up into GitHub. We want all this hard coding we all just did to be protected inside of GitHub. That being said, great job, everyone. We finished this studio. Thank you for working through the studio with me. The next is the bonus missions. Feel free to stick around to see those solutions as well. All right, on to the bonus missions. Now, this bonus mission is a little interesting. First things first, we need to check out a new branch, the bonus mission branch. So I'm going to do this in IntelliJ right now. In IntelliJ, a way you can check out branches much quicker than going through the terminal is that if you see the bottom right-hand side, it says master. Master is what we did all of our studio work on before the bonus mission. We want to check out bonus mission. So I click on bonus mission, and then I click checkout. IntelliJ automatically switches my GitHub branch from master to bonus mission, which saves me a lot of time. Not only that, it refreshes my files for me on the left-hand side. I now see I have bonus binary search, which is another class that we need to test out. That being said, we need to write these tests for that bonus binary search. Now this is where this bonus mission gets a little interesting. What exactly is a binary search? Well, though I'd love to try to explain it to you during this video, I'm going to delegate this to someone who's much better than I am. If you check out this link, it's a great video from HackerRank that will explain to you what binary search is in a much better way than I probably could. I highly recommend you checking out this link before you continue on this video. The link is in the description. So now that we checked out that video, let's go ahead and write a test for this new class. We're going to be writing a very simple happy path test here. In this case, we always start with that public void. And I'm going to call this one int in array returns the index. Of course, we always plug in our annotation there at the top. And this method in that binary search requires two arguments. The first one being a sorted array of integers. The second thing is that if we look very closely at this method, is that it takes in that sorted array as well as 23, the integer of the index we're trying to find. As always, inside of a test, I need to choose an assert to check if my values are correct. In this case, I'm going to do assert equals, where I take in that expected value of 3, because 23 is in the third index of my sorted array, and then my actual value, that method we're testing out, binary search. Let's go ahead and write this test. To start out, I need to have a file that has all of my bonus binary search tests within it. So I right-click on test, I say new, Java class. I place the name of the class that I want to test, which is bonus binary search, and then I put test at the end to dictate that this is a testing class. Inside of here, this is where I'm going to write my tests. As always, we start writing our tests by placing the annotation test at the top. Then public void int in array returns index. Then first I create that integer array of sorted integers. And then I place that assert equals, which my expected value will be 3. And then I plug in that binary search class, that binary search. I see I'm getting a few errors here. So first I'm going to go to the assert equals. I take out test there, and then I need to import this class. So we run this, and we see that it's passed. Perfect. So we're testing out one number here. Let's write another test. I'm going to call this one first int in the array. I'm going to see if it can get the index of 1, which is going to be 0. And the number I want to find is 1. Does this work? Perfect. All right, let's do now at the very end. Let's call it last int gets to return the index. The last index is going to be 4, and that number is going to be 45. Let's run this. Do you see how it keeps running? There's something going on here. We are stuck in an infinite loop. This is not a good thing. We don't want our computer to consistently run, so I'm going to stop this test. I had a feeling this might happen. If we remember reading in our studio, they warned us there's a bug in this class. And that's why we had to write these tests, because we had to try to find it. So it looks like if we try to get the final index of this array, that's when things kind of go a little sideways. So let's take a look at this class. Now going to bonus binary search, this is where our problem lies, somewhere within here. Now remembering that video that I recommended at the start of this task, if we compare her code with how we're writing this here, we see that we're forgetting one major important thing. We're not incrementing or decrementing our mid, meaning that when we're searching this array, we're not moving to the left or the right all the way. Therefore, we're forgetting about the far right part of our array as we're searching, causing an infinite loop. So what we need to do here is actually subtract our mid by 1 if we're moving to the right, and increment our mid by 1 if we're reassigning left. So we save that, go back to our search, run this, and we see now that it's passing. This one was a little tricky, but binary search is a very cool search mechanism to kind of check out. All right, so we officially fixed the bug. So that means we are finished with this studio. We have worked it to the very end and completed that bonus mission. Again, thanks for working this through with me. I hope you enjoyed binary search and got a little bit more out of JUnit and what it's capable of. Thanks for watching.